In this video, I am going to solve this second order homogeneous differential equation. It has constant coefficients and the roots are repeated. The differential equation is y double prime plus 18y prime plus 81y is equal to 0. And the initial conditions are y of 0 is equal to negative 1 and y prime of 0 is equal to negative 3. So first off, we make the assumption that our solution is of this form. Y, let's call it y1 of t, is equal to e to the power rt, okay, where r is some constant. So if this is a solution, it should satisfy this given differential equation, this one. So let's take the first and second derivatives. So y1 prime is going to be equal to r times e to the power t, and y1 double prime is going to be r square e to the power rt. This should be rt. Okay. Now we are going to plug in these values into the equation. That's going to give me r square plus 18r plus 81 times e to the power rt is equal to 0. I have done a little bit of algebra here. Hopefully that's not difficult. I just plugged in these values and then factored out e to the power rt. Now, from our knowledge of exponential functions, we know that this is not equal to 0. E to the power rt is not equal to 0. So it must be the case that the other factor is equal to 0, right? So that's going to give me r square plus 18r plus 81 is equal to 0. I could factor it out quickly. 9r plus 9r plus 81 is equal to 0. And between these two, I could factor out r. That's going to give me r plus 9. Between these two, I could factor out 9. That's going to give me r plus 9. That is equal to 0. Then that will give me r plus 9 times r plus 9 is equal to 0. So the roots are repeated here. R is equal to negative 9 and r is equal to negative 9. So my y1 of t becomes nothing but e to the power negative 9 times t. Now I'm making the assumption that the general solution is going to be y of t is equal to c1 y1 of t plus c2 times t times y1 of t. Now, if I plug in the values, so I get y of t is equal to c1 e to the power negative 9t plus c2 times t times e to the power negative 9t. This is my assumed solution. So we need to find the values of c1 and c2. It's very easy. Let's go ahead and find the derivative first so that we can go ahead and do it all together. So y prime of t is going to be negative 9c1 e to the power negative 9t plus c2 times e to the power negative 9t minus 9c2 times t times e to the power negative 9t. By the way, when I took the derivative, I used a product rule for this expression. T times e to the power negative 9t. Now y of 0 is negative 1. So y of 0 is negative 1. So it's going to be negative 1 is equal to c1. Because e to the power negative 9t is going to be e to the power 0, which is 1. And then there is a t here being multiplied. So t is 0. So this term is going to vanish. So the first equation, this one, gives me c1 is equal to negative 1. Then we could use the second condition. Okay, we could use the second condition, y prime of 0 is equal to negative 3. So that's going to give me from this second equation, is going to give me negative 3 is equal to negative 9c1 plus C2. I already found C1 is equal to negative 1, so it's going to be negative 3 is equal to negative 9 times negative 1 plus C2. Okay, negative 3 is equal to 9 plus C2, and that gives me C2 is equal to 12, and C1 is equal to negative 1. So I could just go ahead and take these values and plug it into this equation. That's going to give me y of t is equal to C1 is negative 1, right? So negative e to the power negative 9t, and C2 is 12, right? So plus 12 times t times e to the power negative 9t. So your final answer should be this, okay? So this is your solution to this differential equation. I hope that this discussion was helpful. Thank you very much.